Alright guys, we're going to look at the Unit 1 test review for this Thursday's test we have coming up. Starting in with number 1, we are drawing a mapping and a graph for this relation. This is our relation, these 5 ordered pairs there. Then we have to determine if this relation shows y as a function of x. That just means, is it a function, yes or no? So, let's start with the mapping. Remember, with a mapping, you list the x values, which are 8, 4, 8, 7, and -3 in order, numerical order, -3, 4, 7. Do not list the 8 twice, only once. Then we have the y's in numerical order, -9, 2, 2, 2, 5. And then you just draw the arrows pointing from the x to the corresponding y. So for this one, from -3 to 2, from 4 to 2, from 8 to 2, from 8 to 9, -9, and from 7 to 5. So there's our mapping. The graph, we're going to just plot the points. 8, 2 is over. Ooh, the calibration is off on this. It's going to be hard to get exactly the right spot. 4, 2, 1, 2, 3, 4, up 2 is like there. 8, -9 is there. 7, 5 there. And -3, 2 is there. So those are our 5 points. Is this a function? Does it show y as a function of x? That is when your x repeats, when the x has 2 different y values, or when the vending machine gives you 2 different drinks, if you want to remember that analogy. This 8 pairs up with -9 and pairs up with 2. This is the cause of it not being a function, not a function. Number 2, similar but very simple. Just, is it a function, yes or no? What's the domain? What's the range? Domain is your x values, which are the first number of each ordered pair. -2, 2, -2, 5. So I'm going to list those. -2, 2, 5. They don't have to be in numerical order, but usually they are. The range, 3. We'll switch to a different color. 3, 5, 6, 2. 3, 5, 6, 2. Is this a function, yes or no? I noticed that -2 pairs up with 3 and -2 pairs up with 6. I'm going to say no, it's not a function because of the -2. Number 3, the domain is the x values, which is -5, -3, -1, 1. The range is the y values, -4, 6, -1, 3. These should have been in numerical order on that mapping. Somebody messed up. That somebody wasn't me. Is this a function, yes or no? Does it ask that? Oh, yes, state the domain and range. I see -5 has 2 girlfriends. That vending machine gives 2 outputs. It is not a function because of that. Number 4, 5, 6, 7, 8. This is evaluating in function notation. So, f of x equals 2x minus 3. This is a function. This is a formula. The x is where you plug in the number that they tell you to plug in. In this case, there's 4 numbers to plug in. -1, 0, 1, and 2. If you do this by hand, you would need to do 2 times x minus 3. And then plug in -1. 2 times -1 minus 3 is -2 minus 3, so -5. I would then go back and plug in the 0. 2 times 0 minus 3 is 0 minus 3, which is -3. Then plug in 1. 2 times 1 is 2, minus 3 is -1. And then we plug in our fourth domain, which is 2. That gives me 4 minus 3 is 1. There's my range. -5, -3, -1, 1. Number 5, I'm going to do this one using Desmos, since we can use Desmos on this test and on your homework and on anything we do. Number 4 I did by hand. Number 5 I'm going to do on Desmos. So here's my function. F of x equals 4 parentheses 2x minus 5. F of x equals 4 parentheses 2x minus 5. That's my function. Ignore the graph. I don't care about the graph. All I care about is this formula. Down here, I can now do f of whatever it is I need to plug in, which I forgot. 0, 3, -3, 2. So f of 0. And then I have f of -3. F of, whoa. F of, what was it? 0, 3, -3, 2. 0, 3, -3, and f of 2. So here is my domain. My domain are these 4 numbers here. My range is those 4 numbers there. -24, -44, -4. See if I can remember those. -20, 4, -44, -4. I think. -24, -44, -4. I believe I'm right. Yes. Range and range. There we go. 6, 7, and 8 are similar, but just kind of one step. There's not multiple inputs. It's just one. F of x is this. G of x is this. We're finding f of -1. That means you take the f formula, 5 minus 3 times x, plug in a -1. That's 5 minus 3 times -1 is -3. 5 minus -3 is the same as 5 plus 3, which is 8. F of 3 plus g of 2. I'm going to find f of 3 first. That's 5 minus 3 times 3, which is 5 minus 9. Need more space. 5 minus 9 is -4. Plus g of -2. G of -2 is 3 parentheses -2 squared plus 2. In your calculator, remember, you have to type in -2 squared in parentheses like it's written here, or else it'll give you the wrong sign. It'll give you a -4 instead of a 4. I know that's +4 though. So 3 times 4 plus 2, that's 12 plus 2 is 14. -4 plus 14 is 10. F of 4 minus g of 3 is the last one. We have f of 4. 5 minus 3 times 4. That's 5 minus 12, which is -7. Minus g of 3 is 3 parentheses. My input is 3, so 3 squared plus 2. This right here just came from that formula right here. And I'm plugging in 3. 3 times 3 squared, well, 3 squared is 9. So that's 3 times 9. Why'd that come out? Plus 2. 3 times 9 is 27 plus 2, which is 29. Negative 7 minus 29 is negative 36. Ooh, ugly. But you get the point. Negative 36. Page 2. Moving to the back. Simplify each expression. Remember, simplify means distribute and combine like terms. So this has no distribution, number 9, only combining like terms. I have a negative 6 and a negative 3 and a positive 4x. If I add all those up, negative 6 and negative 3 is negative 9, plus 4 is negative 5x. Number 10, on my like terms, I have some a's. That's a negative 6a, don't forget that. And I have some b's. I'm going to start with the a's, go in alphabetical order. Positive 6a plus negative 6a is 0a. But no a's, I don't even need to write. So there's nothing there. Only b's. There are 7 b's. 2 and 5 together gives me 7. So, 7b. Number 11, here's where we need to distribute. This is when you have the number outside the parentheses. 4 times x is 4x. 4 times 2 is 8. Minus 5 times 3x plus 6. That is a negative 5 times 3x, which is negative 15x. Negative 5 times 6 is minus 30. Then we combine like terms. 4x minus 15x is negative 11x. Plus 8 minus 30. Combine 8 plus negative 30 and we get minus 22. Negative 11x minus 22. Last one, number 12, another distributive property problem. That's a negative 6x minus 10, and then carry down our minus 4. The x has nothing to combine with, so it just gets brought down negative 6x. Negative 10 minus 4 is negative 14. Number 13, find the domain and range of each graph. Favorite, probably the most difficult, but you'll get over it. Domain, I know, is the x values. X values are from left to right. So I'm looking at my my left boundary to my right boundary. That's the only part that I need to keep, is within that left and right boundary. This is negative 4 to 2. There's 2 boundaries here. I know from my notes, if there's 2 boundaries, negative 4 to 2, I have to have the less than x less than in between. Here, there is no dot, but it appears that the graph equals negative 4 and equals 2 there. So equals and equals. There's no open circles there, so I know to put the equals. The range, I'm going to erase all that because it's cluttering up my graph. The range is the height from bottom to top, the y values that I need. If I were to crop this shape out, I cannot cut anywhere on the bottom because it goes down forever. I cannot cut anywhere on the top because it goes up forever. There are no boundaries here. According to our notes, all real numbers. When it goes forever in both directions, that's all real numbers. Both meaning down and up. Number 14, this one looks like a 2-boundary problem, so it should be a little simpler. The left boundary is there at -4. The right boundary is there at 5. Everything in between -4 and 5. Less than x less than. How we say in between. The solid dot tells me equal to. The solid dot tells me equal to. So there is your domain. The range, same concept, except from bottom. Oh, whoa. To top. Ignore that guy up there. So, lower boundary is 2. Upper boundary is -2 up to 4. Almost forgot my negative. Everything in between -2 and 4 is what we need to keep. The range is -2 through 4. Less than, y, less than. I see a solid dot at both boundaries, so equal to and equal to. Number 15, domain, x's left to right. I see it goes forever to the left, so I cannot crop it anywhere to the left. I can, however, crop it on the right at 1, 2, 3, 4. So the x's, I cannot write it like I did number 14. I cannot do it with the, I do not put that in the middle. Nope. If there is only one boundary, it starts with x. Is x less than 4 or is x greater than 4? Well, on my number line, this way is less than. So all the x's less than 4 are where my graph is. There is an open circle at that boundary, so there's no equal to underneath the less than. Just x is less than 4. The range, the y values from bottom to top, again, it goes down forever, so I can't crop it at the bottom. I can crop it at the top. The highest point this graph reaches is right there at 3. So I need all of the y values that are either less than or greater than 3. Greater than is up. Less than is down. I need the less than values. Now, is it equal to 3 up here? This tip of the graph right there, there is not an open circle, so we assume equal to. We assume it's like a solid dot. So y is less than or equal to 3. Next one, at halftime, the concession stand sold out of every item except for 8 hot dogs. They have $135 in the cash register. They've already made $135. And they earn as much money as possible by trying to sell all of the remaining hot dogs for $3 each. So they've already earned $135. They're trying to earn more by selling the hot dogs for $3 each. So this is how much money they're going to make at the end of the night. 135 plus 3 per hot dog they can sell from here on out. What is a reasonable domain for this function? I know domain is a list of inputs or x values. What would I be inputting in place of this x? That's the number of hot dogs they're going to sell from here on out. Well, it said they only have 8 hot dogs remaining. So they cannot sell more than 8. They cannot sell less than 0, obviously. So we're looking at all of the whole numbers between 0 and 8. So I'm going to say 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh, whoa. Unacceptable. Much better. If there were a lot of these numbers, if it was 0 through 100 or whatever, we could say all whole numbers between 0 and 100. You don't have to list every single thing out. I cannot just say 0 through 8, because 0 through 8 implies every number between 0 and 8, meaning 1.2 or 7.3 or 6.5. I can't sell 6.5 hot dogs at a concession stand, so don't say 0 through 8. There's a test question exactly like this, and if you say 0 through 8, you will get it wrong. Is 141 a reasonable range value? Why or why not? Well, a range value is an output. An output meaning if I plug in all of these inputs, if I sell 0 through 8 hot dogs, can I earn $141? Well, think about our equation. I've already made 135. How much more money do I need to make to get 141? Well, $141, if I take away the 135 I've already made, all I need to make is $6 more. Can I make $6 selling hot dogs that are $3 a piece? Yes, I can. 141 is reasonable, yes, if I sell 2 hot dogs. Is 160 a reasonable range value? I'm going to switch to green for this one. Can I make $160, in other words? Well, I've already made 135. How much more money do I need in order to reach 160? Well, 160 minus 135, I just need $25 more. Well, I'm going to be selling hot dogs for $3 a piece. How many $3 hot dogs can I sell to make $25? Well, if I sell 8 hot dogs, that's the most I can sell. That's my highest amount. 8 times 3 is only 24. That's the most extra money I can make. Can I make 25 more to make it 160 total? No. Even if there were more hot dogs, I can't get $1 extra to make this 25. That just won't work. It's not a multiple of 3. It's not going to be able to, I'm going to say not enough hot dogs. Or I could say it is not a multiple of 3, so I can't make enough money to total $160. Last question, or 2 questions, I guess. Draw an example of a graph that does not, I'm running out of space. I don't want to erase everything because I want to leave it up there for y'all to see. That does not represent y as a function of x. This is the vertical line test. If it is not a function, then it has to fail the vertical line test. This graph right here fails the vertical line test at that spot, not a function. Number 20, draw an example of a graph that shows y as a function of x. So this is a function. This needs to pass the vertical line test. As long as it doesn't overlap itself, then it is a function. So something as simple as that. There is nowhere that a vertical line, like this green, can cross that blue line at 2 places at the same time. It'll only intersect the blue line once. So that is a function. At the same time, over here, the vertical line test fails because it can cross the blue squiggly line twice. There's a whole bunch of different correct answers from here. You could have something like, you could get crazy, and that passes the vertical line test. That's a function. You could have that passes the vertical line test. You could have that pass the vertical line test. You can get very creative. All of these are functions. On number 19, you can also get creative here as long as it has an area sort of like that where it fails the vertical line test. That's not a function. It could be as simple as that. That fails the vertical line test right there. So as long as it overlaps itself, then it's not a function. That is your test review. Hopefully you were able to complete all that, or at least understand and get whatever questions you had answered by me. Good luck.